What are fatty acids? Fatty acids have general formula CH3CH2NCOOH, where this N, now basically it starts whenever N is 2. So if N is 2, that means 2, 3, 4, butanoic acid. Butanoic acid onwards are all fatty acids. Alright, so we would be dealing with fatty acids with carbon number 12, 14, 16, 18 onwards. Alright, so if this is 10, N is 10, then it would be 10 plus 2, that is 12. It would be lauric acid. If N is 12, then 12 plus 2 would be 14. That would be myristic acid. And if this is N is 14, then 14 plus 2, it would be 16. That would be palmitic acid. And if it is 16 plus 2, that would be 18, that would be stearic acid. Alright, so on, so forth, that would go on. So these are the fatty acids. So these are called as saturated fatty acids. Whenever the fatty acids have unsaturation, we call it as unsaturated fatty acid. For example, stearic acid we told is C, here N is 16 plus 2, 18. So stearic acid is fatty acid with altogether with 18 carbons in the molecule. Alright, but this stearic acid, if it has got one double bond, then it is called as oleic acid, and if the molecule has two double bonds, then it is called as linoleic acid, and if it has three double bonds, then it is called as linolenic acid. So these were examples of unsaturated fatty acids, whereas saturated fatty acids are when there are no double bonds in the molecule. Alright, so these fatty acids react with glycerol. Glycerol is what? CH2OH, CHOH and CH2OH. So fatty acid, three molecules of fatty acid, because there are three sites of reaction, that is 3 OHs available. So three molecules of fatty acids react with glycerol to give triester, also known as triglyceride. Triester because we know C double bond O is ester group, so it is triester or triglyceride. Why? Because this is glycerol, so triglyceride. Alright, now how are we moving towards micelle? Okay, you would feel that, oh God, we are moving towards chemistry other than micelle. No, understand it. Now, oil, if I say coconut oil, or coconut oil is also a triglyceride. Now it is the fatty acid involved in formation of triglyceride is lauric acid. So it is trilaurate or trilaurine is the coconut oil. Coconut oil is edible and for application as well. Alright, so that is example of triglyceride. Okay, now how do we, so what? If I take coconut oil for example, which has got C12, triester, trilaurine, and I treat it with sodium hydroxide, heat it and reflux it. Hydrolysis occurs. What we end up with is glycerol and sodium laurate. Alright, so glycerol is the byproduct and this is the soap. And since we are forming soap via this process, so we call this process as saponification. Alright, so saponification. Why saponification? Because we are ending up with formation of soap. Alright, now why do we call it as soap? What is greatness about soap? Greatness is that the soap is a surfactant. What do you mean by surfactant? Surfactant is surface acting agent. Now see, it has got a head and it has got a tail. This part which is there is lipophilic, that is oil loving, fat loving. This part which is there is hydrophilic, water loving. Bigger the tail part, better the lipophile, better the lipophilic character, and more the head, better the hydrophilic character. Now what do we mean by tail is understood. Okay, we have got carbon, 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 CH2, 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 CH2. That makes tail. Like for example, lauric, better than lauric would be myristic, then palmitic, then stearic. Alright, C12, C14, C16, C18. So 18 would be the best lipophile, C12 would be a bit poorer lipophile with respect to stearic. Alright, okay, that way. So this part is understood. Now, what about this part, head part? Head part, more the polarity is, the more hydrophile it is. Alright, because we know water is polar because it has got O delta negative, H delta positive. So water is bipolar. Alright, so the more the polarity, more the molecule would be soluble in water. Alright, now for lipophile or hydrophobic or lipophilic, long alkyl chains, butyl, pentyl, hexyl and above. Alright, so the bigger it is, the better hydrophobic and lipophilic would it be. And here in this case, suppose the molecule has more number of hydroxides. So obviously that would be, for example, if I take propanol, which is if we take example of propanol, 1-propanol and glycerol, both of them are 3 carbon molecules, 1, 2, 3, 1, 2, 3, 3 carbon molecule, but here it has got only one hydroxy, which is hydrophilic, whereas here the molecule has 3 hydroxys. So this obviously we expect it to be more hydrophilic than propanol. Alright, now just to understand this, we have got to understand a bit of a scale which is HLB scale.